You've seen those insanely beautiful images of space, those colorful clouds that look like paintings? They're not just cosmic decoration. That's a nebula. And behind all that beauty, there's chaos, creation, and death. Nebulae are massive clouds of gas and cosmic dust scattered across the universe. But they're not just floating there looking pretty. They're star factories, literally. Inside these turbulent clouds, gravity starts pulling gas and dust together until everything collapses. And then, boom, a new star is born. But here's the darker twist. Nebulae are also stellar graveyards. When a star dies, in a colossal explosion called a supernova, the remains become this, a new nebula. So basically, nebulae are the beginning and the end, the full cycle of cosmic life. Every time you look at one of those breathtaking images, you're seeing a story of birth, destruction, and rebirth written in the language of the universe. And here's the wildest part. Everything in you, every atom in your body, came from a nebula. You're made of the same stuff as those clouds. You are, quite literally, stardust. To understand what a nebula is, we first need to think about what makes up the universe, not just stars, but everything that doesn't shine. Nebulae are gigantic clouds made mainly of gas and dust, spread across space, sometimes even larger than our entire galaxy in some cases. The gas in these nebulae is mostly hydrogen, the simplest and most abundant element in the universe, along with a mix of helium and other elements in smaller amounts. The cosmic dust consists of tiny particles that look like smoke, but are made of elements like carbon, oxygen, silicon, and iron. This combination forms these clouds that, despite appearing light and ethereal, can have an enormous mass, billions of times the mass of the sun in some giant nebulae. But why are these clouds there, and what holds them together? In space, gravity is the main conductor. Even this dispersed matter exerts a force that can cause gas and dust to start gathering. In some regions, the density is higher, and the gravitational force pulls in more material, causing the cloud to collapse gradually. This process slowly forms the seeds of stars. These dense regions are called condensation cores. Besides gravity, other forces and cosmic events influence nebulae. Radiation from nearby stars can heat parts of the cloud, ionizing the gas and making it glow in vibrant colors. Shockwaves from stellar explosions can compress the nebula, speeding up star formation. Invisible magnetic fields shape the clouds and either hinder or help the collapse. The result of this interplay is that nebulae have surprisingly varied shapes. Some look like ghosts, others like hearts, horse heads, or true explosions of light and color. Emission nebulae. These nebulae shine intensely because their gas is ionized by nearby young, hot stars. Hydrogen, when excited by ultraviolet radiation, emits characteristic red light, the breathtaking glow we see in these images. This is where star birth happens rapidly, a true stellar nursery. Reflection nebulae. Unlike emission nebulae, they don't glow on their own but reflect the light of nearby stars. The reflected light is usually bluish because dust scatters blue light more efficiently than red, the same phenomenon that makes Earth's sky appear blue. Dark nebulae. These are dense and thick enough to block light from stars and nebulae behind them. They look like black spots in space, like patches of fog where light simply can't pass. In reality, these are regions where gas and dust are so condensed, they may be about to form new stars. Supernova remnants. These are the debris left after a star dies in a colossal explosion. This cloud expands rapidly, glowing intensely across various parts of the electromagnetic spectrum, from radio waves to X-rays. The famous Crab Nebula is a classic example. Planetary nebulae. Despite the name, they have nothing to do with planets. They are gas envelopes expelled by stars like our sun in their final phases before becoming white dwarfs. These nebulae often have symmetrical shapes and bright colors that both fascinate and puzzle astronomers. They're much more than just pretty objects in the sky. Nebulae are the life machines of stars, turning simple matter into stars, planets, and indirectly, everything we know. When stars are born, live, and die, they enrich the interstellar medium with heavier elements, carbon, oxygen, iron, produced only in the star's furnaces. These elements are thrown back into the nebulae, enriching them for the next generations of stars and planetary systems. It's a continuous cycle where nebulae are the vital link between death and rebirth in the universe. You're looking at a colossal cloud of gas and dust floating silently in space, undisturbed for millions of years. Suddenly, an invisible spark, maybe a nearby supernova explosion, maybe just gravity doing its thing, triggers a chain reaction. Gravity takes over and begins pulling everything inward. The nebula starts to collapse. And just like that, a star is born. But this process is far from simple. The birth of a star starts with the collapse of a dense region within the nebula, known as a protostellar core. Gravity begins to overpower the internal pressure of the cloud, causing it to slowly contract. As gas and dust pile into the center, density and temperature soar. This can take millions of years. The collapsing core heats up so much it begins to glow. Not from nuclear fusion yet, but from raw thermal energy. At this point, it's called a protostar. The protostar keeps growing, pulling in more and more material from the surrounding nebula. Eventually, the core reaches temperatures above 10 million degrees Celsius. This is the tipping point. At this temperature, hydrogen atoms begin to fuse into helium, releasing an insane amount of energy. Nuclear fusion becomes the main source of heat and internal pressure, balancing the force of gravity. Now we have a true star, a self-sustaining ball of fire. This whole process can take 1 to 10 million years, depending on the star's mass. Not all stars are born the same. The amount of material gathered during the collapse determines the star's fate. Small stars like our sun burn slowly and live for billions of years. Massive stars, dozens of times the sun's mass, burn fast and die young. In spectacular supernovas, some objects don't gather enough mass to start fusion. These become brown dwarfs, failed stars that glow dimly like a piece of glowing coal. Around the newborn star, there's still a lot of leftover gas and dust. This forms what we call a protoplanetary disk, a swirling ring of debris. Over time, this material clumps together to form planets, moons, asteroids, and comets. Yes, planets are born from the leftovers of star formation, which means everything you see and from Earth to your smartphone came from nebula dust. When a star dies, it releases its elements back into space through solar winds or powerful supernova explosions. That material mixes with the interstellar medium, giving rise to new nebulae, and it all begins again. Nebulae are beautiful, no doubt about it, but their value goes far beyond their visual spectacle. These vast cosmic clouds are like ancient textbooks, written in stardust and light. They hold secrets about how galaxies evolve, where matter comes from, and what may become of our own solar system. Inside these clouds, the universe is busy at work. Radiation blasts through gas and dust, triggering chemical reactions that build complex molecules, some of which are the very building blocks of life. Scientists have found organic compounds inside nebulae, simple amino acids, formaldehyde, and even molecules like ethanol. That means the chemistry that gave rise to life on Earth may have started long before Earth even existed. Life, in a way, could have been born inside a nebula. For astronomers, these structures aren't just pretty pictures, they're natural laboratories. By studying them, we unlock the story of how stars are born and how they die. We uncover the chemical recipes that build planets. We even track invisible forces like gravity and magnetism at play across millions of light years. And speaking of invisible forces, nebulae are shaped by magnetic fields. You can't see them directly, but they weave through the dust and gas like hidden scaffolding. These fields guide the flow of particles and sculpt the structure of entire regions of space. Astronomers use special instruments that detect polarization to see these magnetic lines and map the unseen architecture of the cosmos. But here's the thing. You'll never spot most nebulae with your own eyes. They're too faint, too distant. That's why we rely on telescopes. The Hubble reveals the vibrant, visible light, The James Webb peers through dust and infrared. Radio telescopes detect molecules and cold gas. And X-ray telescopes like Chandra show the heat of violent stellar deaths. Together, they give us a complete picture of something we were never meant to see, a side of the universe hidden in plain sight. And one day, this story will come full circle. When our sun dies, it will cast off its outer layers and form a nebula of its own, perhaps one as haunting and delicate as the cat's eye. Nebula. Billions of years from now, our solar system may be just another cloud drifting through space. A distant civilization might look up and see it glowing faintly in the night, the final trace of a world that once called itself Earth. Out there, beyond the glow of our skies, nebulae are writing the future of the universe. And maybe, just maybe, they already wrote ours. If you want to keep exploring these cosmic mysteries with us, don't forget to subscribe, hit the bell, and leave a comment. What do you think is hidden in the dust between the stars? The next secret might be closer than we think.